Everyone, welcome to Simplifying Complex Rational Expressions. So when we have a complex rational expression, it means that we have a numerator, denominator, or both that also has a fraction. So it's a fraction like 5/9 within the larger fraction. Okay, so we're going to start with just real numbers here, and we're going to kind of review what this means. So the first thing I need to do before I divide by 16 is I have to get the numerator to be one fraction. So I have 5/9 minus 1/5. Okay, and that's going to be divided by 16. And I'm going to leave that 16 alone and kind of work down the left side. I know that the common denominator is going to be 45. Okay, I'm going to just multiply 9 times 5, and that's 45. So in order for 9 to get to 45, we multiply it by 5 to the top and the bottom. So 5 times 5 is 25. And I know that in order to get 5 to go into 45, I've got to multiply that by 9. So I do the top and the bottom by 9. Okay, so 9 times 1 is 9, so I get plus 9. Or excuse me, minus 9 there, because there's a minus sign. So let me go ahead and erase that. So we're going to have minus 9 there, so we have minus 9. That minus is for this one right here. Okay, so that simplifies, and remember we still have the divided by 16 here. I'm just working the left side right now. 25 minus 9 is 16, so I'm going to have 16 45ths, and that's going to be divided by 16. Okay, so let's work our way back up here. So we have 16 45ths divided by 16. And we can put that over 1 if we want. So remember, we divide fractions, we take the second fraction, okay, and we flip it and we make that multiplication, so 1 over 16. And since we're multiplying now, we can simplify going up or down or straight across. 16 goes in itself once, 16 goes in itself once here. 1 times 1 is 1, and 45 times 1 is just 45. So 1/45 is equivalent to this expression. So let's get into something that's a little more complicated. So in example 2, now we see we have a rational expression, but we have a fraction inside of another fraction. We have a fraction in the numerator and a fraction in the denominator. So what I'm actually going to do here is I'm going to leave the numerator alone first. I'm going to have 2 over x plus 3, and that's divided by, there's the division sign, divided by 1 plus 3 over x. Before I flip this, I'm going to get one fraction here. So I'm going to leave the left side, or the left side of the division sign alone. Okay? And I know that if this is over 1, the common denominator is going to be x. I'm just going to multiply my denominators straight across. So in order to get 1 to be x, I have to times x here and times x in the numerator. Well, 1 times x is x. The second part of this fraction already has the denominator, so it's just going to be plus 3 here. I'm not going to do anything else. I now have a single fraction. Okay, so I have 2 divided by x plus 3 divided by x plus 3 over x. So I'm going to go ahead and leave the left side now. 2 over x plus 3. I'm going to change to multiplication, and that means I have to flip my fraction, my rational expression. So it's x in the numerator over x plus 3 in the denominator. So what I do now is just multiply straight across, because I can't simplify going vertically and I can't simplify going diagonally. So I get 2 times x, which is 2x, all divided by x plus 3 times x plus 3, which is x plus 3 squared. Okay, in this case, x can't be 0, right, because that'd make this 0, and x can't be negative 3, can't be negative 3. So there's our final answer there. All right, last example here gets a little more complicated. We have 3 over x squared plus 5x divided by negative 2x over x plus 5 plus 1 over x. So a lot going on. So again, I'm going to go ahead and rewrite this. So 3 divided by x squared plus 5x divided by, this division sign is the big bar right here, divided by negative 2 over x plus 5 plus 1 over x. Okay? So what I'm going to do is leave the left side alone and work the right side. So x squared, 3 over x squared plus 5x stays. I'm not going to flip yet. I need a common denominator. So x plus 5 times x is going to be the common denominator here. Just multiply your denominators together. That gives you a common denominator. X plus 5 is missing the x. So the top and the bottom here are going to get multiplied by x. So negative 2 times x is negative 2x. I'm going to bring that plus sign down because it's plus. X here is missing the x plus 5. So remember, that has to be multiplied by x plus 5. We've already done that. It's already down here. Look, already together. And the top has to be multiplied by x plus 5. Okay, so 1 times x plus 5 is just x plus 5. I don't have to worry about the plus sign. The signs here remain the same. So I'm going to come up over here. We can scroll down a little bit. So we have 3 over x squared plus 5x divided by, well, negative 2 plus 1 is negative 1x plus 5 over x times x plus 5. Okay, can't cross these out, different signs on the x. So let's go up here and we're going to rewrite this as multiplication. So we're going to take multiplication and flip our fraction, and we get a rational expression, x times x plus 5 over negative x plus 5. Notice on the left side here we can factor out an x. So I'm going to go ahead and do that. Okay, x squared divided by x is x. 5x divided by x is just 5 times the right side now. And we'll have some things that cross off. So let's look. X goes into itself once, x goes into itself once, x plus 5 goes into itself once, and it goes into itself once. So we are left with just 3 over negative x plus 5, or you could say 3 over 5 minus x, doesn't matter. In this case, if you're looking, x can't be, let's look back here, x can't be 0, okay, and when we go to multiplication, x can't be 5, okay, so there's our final answer. So if you have any questions or comments about complex or simplifying complex rational numbers, go ahead and type them below, and we'll see you next time.